Yeah. So we are coming back here to our uh, point of discussion, that is data dissemination. So idea is that you are having your sensors WSN nodes deployed over a region, and now when I say now for in context of our IOE, so these nodes they have to transmit the data, and this data need to be collected at some point. So this is now our objective. Now for a large population of these IoT nodes, how to collect data, what are the possibilities, okay, how the traffic should be routed, how the data should be collected, because depending on your application, the node may be static or maybe dynamic. So depending on it is overall no ad hoc network or static network kind of thing, a number of things are there. Idea is that in these variable conditions we have to collect the data. Okay, and essentially, when you say that these IoT deployments, they are actually a part of our type of WSNs only, a special situation, or even as it is, they have got nodes and their data collections, because now WSN has now taken the what you can say shape and form of our IoT communications, Internet of Things. Hmm. So data has to be collected and data has to be diffused. How to do that? For that we have to find ways. So one part is that now find a mechanism where from various number of sources I have to collect data at regular interval. Okay, and this data now here in previous lectures we have seen that in WSN there is a concept of base station. In our IoT deployment there is a concept of your gateway node, or there is an edge device, edge device which can collect and pass the data. And when data has to be, we say the data diffusion is there, is data collected from various source. At one point it is then packets are reformatted, and depending on this edit they are forwarded to the next hop or next destination. So again, this model also followed in our IoT deployment. So this your COAP protocol, this your MQTT protocols in some or other way they do this thing. Even your Amazon IoT core services, so they are having this publish subscribe model. When these sensors and these nodes are registered and this data will be pushed to that what you can say node. So some or the other way you will have to work on this data diffusion over the thing. So there are the concepts source, event, and sync. So source is what the sensor node which is actually uh, generating the data. So maybe it is sensing temperature, pressure, and humidity, and data packet is generated. Then based on that, this data packet is generated, maybe some event is triggered, or at some regular time interval this data is passed to the what you can say your either edge node or the base station. And there is a concept of this sync in this WSN, where the node which is randomly located, okay, it gathers the data temporarily, that sync. So actually here in IoT this concept is called as sub subscribe model, pub sub model, actually it is called as publish and subscribe. So source they actually publish, and the sync they actually subscribe technically. So this is actually I'm linking this so data diffusion model to your pub sub model. Maybe this this COAP and MQTT protocol they use this kind of models. Okay, so MQTT is actually there is a message queuing telemetry and transport. So this message will be pushed, and there is MQTT broker which will be collecting the data. Whereas COAP they are using publish and subscribe. These models are there. So this detail will come in what you can say next steps. So idea is that anyhow in WSN from one part A to source to destination, and when direct communication is not possible, then you have to find a mechanism how the data reaches to the destination through this path. So for that, what are the mechanisms? Let us go ahead. Yeah. So yes, this data diffusion concept I just briefly what you can say describe. So here you can see one tiger and tiger collar okay, is a source where this tiger is moving through what you can say the jungle, and the location is there. Now here I am having another thing where you can say this. How yesterday someone asked me uh, regarding the sensor. So this is the BME280 sensor, and I can this BME280 sensor I can connect to this no ESP8266 board, and this is becoming a source now. And then in your what you can say in your WSN deployment, IoT deployment, you choose that okay, this node A become sync, and then this will add to this what you can say data collection, data gathering, and data forwarding mechanism. So now this node will be transmitting, and this node will be receiving, and then gathering this data together, and then forwarding the packets to the next node. These are the concept of source and sinks in the what you can say the what is diffusion concept. Then there is some one more thing called as no data centric versus address centric architectures. So many times as we have seen that this WSN deployment are ad hoc, or these devices they are very what you can say no small in compute power and storage. So because of that thing, the kind of protocols or the mechanisms which you use for internet, they may not be directly applicable there. We have to modify them. For example, even MAC protocol, which is there used by our internet nodes on our computer networks, it is normal conventional MAC for the sensor networks. There is a sensor MAC separate protocol is there, which is kind of a scaled down version or tweaked version so that it runs what you can say specifically on the low power devices. Okay, so here there is a concept data centric architecture and address centric architecture. So our this internet this conventional TCP/IP network, it is address centric. So everything is what you can say 192.168, which is a typical private address 0.1. So from this node and this node, the data is emerging, and then through gateway address NAT and other thing, this data will go to other point your server. Then it will request this website, and the communication will be there. To and fro communication is there. So mainly this, and again this server may have no some address 1.2.3 kind of thing, public internet address, and they will be communicating from here. They will be, gateway will be there, and gateway and this node they will be communicating. So address-centric architecture. Here, data-centric architecture means what? Generally, rather than address of the sensor node is not that important. Rather, that data, what is it sensing is important. So with each, what you can say, data packet like temperature value is suppose 40 degrees Celsius, and pressure value is 0.11 bar kind of thing, and humidity is now suppose 10%. So this is the triplet. It is generated, and I'll just say that this S1 sensor one. So that's all. This packet is generated, and this packet should reach to your base station somehow. So it will come to know, okay, sensor one sending this data packet, and maybe you can add timestamp, or so maybe your 11:10 a.m. is a timestamp, or even this is not required. The moment the data packet is received here, that can be acting as a timestamp. That's all. So this no here name data concept can be seen here. This data and source and identifier is there rather than address. So data is important. How data is reaching the source destination is important rather than how no this routing and other things are done. Okay, so that's why this interest there is concept of this source. There we have seen in the previous lecture, previous slide. Here you can see this is a source and this is a sink. So sink express interest. They say that I want to gather the data. So it is something called as a subscribe concept. Remember this thing, because now this sink is actually wishes to okay, I want to gather the data, so it will seek on what are the various nodes which are actually transmitting the data. So it is technically subscribing the thing, subscribing the reading from a node. Okay, so yeah, sink node request data by sending interest for data. Okay, and then interest is propagated through the network, setting up gradients in the network designed to draw the data. So yes, if there are multiple nodes are there they are going to get okay, this S1 sync 1 is having interest. So yes, whenever some packet comes for this sync node, they are going to transmit that thing. That is the idea. And then path will be discovered. The sync can reinforce the path, and the packet will be reaching. So this is the mechanism. So there are protocols which will be using this mechanism. Okay, yeah. So this data gathering we have to do. One protocol we have already seen, this Leach protocol. Briefly we'll reiterate that thing here. So Leach and Pegasus, these two question will come for 8 to 10 mark in your final examination. So idea is that base station wants to collect data from the sensor nodes. Okay, so there is one to establish the path. Let's establish the path. There are some metrics, okay, which will be used, and these metrics are this energy into delay metric. Okay, it is like there is one very important thing called as cost. Hmm? So for each path, this cost is involved, and this cost is energy into delay, because for this highly constrained WSN or IOE deployment, energy is also one, what you can say, important factor, and delay is also one important factor. So they both constitute for the path cost. Remember this thing, because in the these are like, it will indicate how the data is going to reach. Yes. So yeah, here we'll see that now this Leach we have seen low energy adaptive clustering hierarchy. So when what you can say, uh, nodes will be clustered based on their vicinity. Then in every cluster we'll select a leader randomly, and this in every iteration this reader will be changing, and these nodes will now send the data to this leader. So because of that thing, what will happen? They will have to send it to nearest one, so that delay will be less as well as energy consumption will be less. So low energy consumption will be there, and this leader will gather this data packet, fuse them, and then send it to base station. So again it doesn't need to transmit n number of packet, rather it transmit only single packet, which is based on, I can say, uh, combination of all data which is coming from the cluster. Okay, so yes, these things we have seen designed for sensor network. Okay, hundred to thousands of node. It maximizes the system lifetime. This network coverage is maximized because now clusters are there. So these clusters, they can be spread over the, what you can say, region, and then we can put one leader node, which are the bigger ones. They can communicate with the base stations. Okay, so leader nodes will only communicate with the base station here. So that will actually maximize the network coverage, because this single network base station cannot communicate with all nodes, because even nodes are having limited power. But this leader node, this if a node is capable of transmitting at a bigger distance, that will be treated as a leader. Okay, so that's why this then leader will go for local processing to reduce the global communication overhead, and then there will be randomized rotation depending on the capacity, and leader will be selected, so that overall this process will be actually maximizing the system lifestyle. Okay, system lifetime. So here you can see that this cluster 1, cluster 2, cluster 3 base station, and now these nodes are communicating. This is a simpler cluster. Here's a Leach protocol. There's a low energy clustering hierarchy, adaptive clustering hierarchy. Then second protocol that is important, that is used by your WSN deployment, is the Pegasus protocol. So this Pegasus protocol has some different mechanism. It will not work on cluster, rather it will work on paths that I just discussed, energy into delay. That metric will be used to calculate the cost for the path, and it will find a path with the least cost or the maximum efficiency. So goal of Pegasus is power efficient gathering for sensor information system. So this WSN wireless sensor network, these are IOE networks. So applies for that, and power efficient gathering. We have to gather data by efficiently finding the path. So it minimizes the distance the node must transmit. Okay, number of leaders are also minimized, which transmit to base station. Broadcasting overhead it minimizes, and minimize number of message that leader needs to receive, and it distribute works equally among all the nodes. So what it is using? It is using greedy chain algorithm. So what it does, it starts from the farthest node. Here you can see it starts from the farthest node, and it will find the node which is having least cost nearby to this node, and from this node, so there you can see 1 2, 3, and 4 nodes are there. But for all these 4 nodes, only this node has got least path currently. So it will try like this for the destination. At every node, it will keep on finding least path and it will reach the destination. Though this path, what you can say, it may be smaller one, but heavier one, lengthier one, but overall, this is power efficient because at every node, this node will try to find a node will be transmitting on the least path, that particular node. So at every node, there is always low expense on the transmission, low expense on the transmission to the next path. Overall, you may think that it is actually here this path is the shortest one, but for this node, this path has got more consumption because every node has to be sustained in the network. They are part of the network. Suppose some node fail, fine, then alternate path will be found and this will be taken. So this is having fault what you can say robustness as well as sustenance when paths are there. So there are schemes. So where the chain based descriptions are it can be seen here. So at step 1, step 2, step 3, so how these nodes are, they will just have one level C0 to C1, C2 to C3. Every node will have this path, every node will have this path. What is my next path for what you can say reaching to the uh, next level of my destination node, to the base station. And whenever any packet comes to this C0, it will go to C3, C1, C1 to C3, C2 to C7, like that thing. And then in C7, here it is missing to, sorry, sir, C3 to base station, like this thing. If it is goes to C4 to C5, C5 to C7, C7 to C3, C3 through base station. Like this thing, this path will be there. So these two, mainly in your final exam, this power efficient gathering, and for every node, we have to find out delay energy into what you can say delay cost energy into delay, find the path. For every node, find the best or least cost path, store that in your hierarchical table, and then follow the path. Then we will just briefly discuss. There is sensor MAC protocol. Go through that. So, so this question comes in your exam is that SMAC. Okay. So this sensor MAC protocol is a modification of your MAC protocol. This MAC protocol is used by medium access control protocol used by your Wi-Fi uh, that device which is communicating, and at physical level how these two what you can say nodes will communicate with each other. For example, this laptop has got my LAN card is having MAC address, and this LAN card is going to communicate with the hub, and in hub to switch to router, and like this thing it will go on to our gateway. And this so packets are again transmitted between two devices, and these devices will have physical address. This is like, so even for your sensor nodes, as they are having these communication interfaces, they will have to have this MAC address, because we have seen this even this node MCU, we had that thing, or Node 32, both the device, both of them, they had 802.11b G incompatible. So it has got 802.11 interface. And this interface will have this this in a MAC address, but this they will be using this SMAC, sensor MAC. So what is this? Okay, why they are required? So here you can see we have already discussed this in battery operated limited power. Then this the wireless sensor nodes, they are other what you can they work in condition where this large number of nodes are together, and these nodes are having operational constraint of less number of, what you can say, they have very less compute power, low battery, low storage, low memory. Okay, and ad hoc fashion is there. So large number of nodes in ad hoc fashion in the deployment. So because of that thing, we have to have energy efficiency and scalability in the data transfer. And so what happens when this large number of nodes they communicate on the, what you can say, wireless medium? So collisions occur, packet collision, overhearing, then packet overheads when the packets are gathered, because if you say that Pegasus or no Leach protocol, the leader node is getting data from other, so then it has to process that. Okay, remove the overhead, take the data, and then form the, what you can say, data packet or no this address and data and, what you can say, identify packets and transmit it. And so because of that thing, that overhead we have to deal with in idle listening. So this sensor network, when they are doing nothing but waiting for data, so that is idle listening, and it has to be go, what you can say, over the time. Again, we have to save the battery also. So all these things should be handled so that there is efficiency. Otherwise, if they are handled in a conventional way, they will result in inefficiency. Okay, so what existing MAC designs are there? They are contention based protocol. So when two, what you can say, packets collide, the contention occurs and retransmission will be initiated. Then 802.11 idle listening is there. Then TDMA based protocols are there. So we have to modify this existing MAC so that it works with our sensor network. So three goals are there: reduce energy consumption, good scalability because 10, 100,000 nodes might be there, and self-configurable because when you are having these hundreds of nodes deployed, suppose some node go out of service, still your network should be functioning. So self-configurable. If some things are not reaching at the destination, we have to find the alternate route. Okay. So this SMAC tries to reduce the wastage of energy and improve the efficiency. Then it detects the collision by using request to this RTS and CTS frames. They are conventionally used in your network communication. And when, what you can say, there is transmission is not, what you can say, meant for the specific node, it will switch off the radio. So overhearing is, you are stopped here. So if I am not part of this communication, my radio is switched off. Or having, what you can say, idle listening is, what you can say, very low listening, or that will be done by your idle listening, a periodic listen and then sleep. So in a typical time frame, it will not keep on listening for all time. Rather, it will listen for some time, again sleep for some time, listen for some time, sleep. So because of that thing, yes, some uh, it might not be optimized, but it is very energy efficient. Okay, it may incur some delays, but it saves your, because the power efficiency is the first goal of your sensor map. Okay, that is actually mentioned here. So there reduction in per hop fairness and latency. So because of that thing, these improvement which are in the sensor mesh, they are bit slow. Okay, they are bit slow. So basics are only, what you can say, applicable in your uh, IoT deployment. I'll stop here. We'll, yeah, thank you. Just I'll end the live.